Hello, this is Julie Lerman.
And this is Steve Smith. In this module, we're going to wrap up our course on domain-driven design fundamentals by showing how we can reap the benefits of our design when it's time to add additional functionality to the system.
In this module, we'll first review our current system design and see how it incorporates DDD patterns and practices. Then we'll circle back to our customer, Michelle, to see how the new vet clinic appointment management system is working out.
During that quick conversation, we'll learn about a new feature, and we'll show how we can implement that feature.
We'll leverage message queues to implement this feature, so we'll definitely be sure to share with you some of the basics about message queues before we show you that code.
The main benefit of our design choices is the ease with which the system can be extended and maintained in the future, and we hope you'll agree that adding to the current design is quite straightforward. So far, our system is pretty simple, though it's fairly complex as most course demo apps go.
The system is currently two different web applications, although the user interface makes it look like a single app. Our main focus has been the application used by clinic employees to schedule appointments. There's a lot of complexity with scheduling, so this benefited from domain-driven design. There's also a clinic management application that's used to do simpler data in, data out tasks like record keeping and maintaining information about doctors, clients, patients, and more. Let's review the scheduling app a little more closely.
We have a single aggregate for a schedule, which contains a number of appointments. We limit access to the schedule through the schedule repository class, which is responsible for retrieving and storing the schedule in our database. We've identified a couple of value objects that allow us to better model concepts in the domain, and we're making use of domain events to allow our domain and other parts of our system to respond to changes in the state of our model.
It's taken us a while to get to this point, but now that we're here, the design of the system is very clean, and it reflects the customer's domain as well as we've been able to model it so far, of course, given some time constraints.
Yes, we do have to ship the app, this course, at some point.
Right. Of course, as we build on this application, our model would continue to evolve, but we've shown you techniques you can use to ensure that you can grow the application without being overwhelmed by the complexity you're trying to model.
Actually, as it turns out, the customer does have one more request for us. She said something about customers forgetting their appointments. Let's have another quick conversation. As it turns out, the customer does have one more request for us. She said something about customers forgetting their appointments. Let's have another quick conversation.
Hey, Michelle, great to see you. How are things going with the new scheduling application?
It's been fantastic. We're really able to see very easily who's scheduled each day and book new appointments and move things around as needed. And the front desk folks really appreciate that it highlights the appointments that are conflicting or confirmed. That makes it much easier for them. But one thing that's still a problem is the fact that sometimes our clients forget their appointments. It probably happens at least a couple of times every day, and our staff really don't have the time to call every client to make sure they remember ahead of time.
So you'd like the system to call them then?
Well, we understand there's services that'll do that sort of thing, and we might move to that eventually. But for now, if we could just send an email, that would probably help remind clients to put it in their calendar.
Oh, okay. So do you want an email to go out when they schedule the appointment or on the day before they're scheduled to come in, or maybe even both?
Oh wow, if we could do both, that would be great. One to let them know when they've booked, so they know that we've got it in our schedule, and another one to remind them that they have an appointment the next day, just in case they forgot.
That shouldn't be too hard. Our model already handles certain events that occur, like when appointments are scheduled. And appointments already support being marked as confirmed, too.
Sure. And I think all we really need to build that'll be new is some kind of service for sending the emails and some way for clients to click a link in the email so they can confirm the appointment. Since it's email, it shouldn't be a problem to send these out the day before, even if that day isn't a weekday or a work day, right?
No, I think that should be fine. It shouldn't hurt anything to send an email on a Sunday or a holiday. And of course, we'll ask our clients to opt into these reminders so we're not sending anything unsolicited.
Sounds good. We'll get started and should have something for you to review real soon.
Before we get into the gory details of the implementation, we just want to make sure that you understand the very high level of what we're doing here. The first thing is triggered when the appointment is scheduled. And in response to that, our system will send a confirmation email to a client.
Once the client gets that confirmation email, they can click a link to confirm that they're going to make it to the appointment, and the system will then mark that appointment as confirmed so that on the schedule, the staff will see that it's got a green box around it and they should expect the client will actually show up.
What's nice about this implementation is that it benefits so much from a lot of the infrastructure we already have in place. And thanks to our DDD-based architecture, it's just as easy to add in a few extra features that we need to make this work.
So as we go through this, you'll see us using some existing and some new domain events, some application events, a number of event handlers and services. One new tool you'll see is something we haven't talked about yet, messaging queues, to communicate between separate applications. The application we've been working with will need to communicate with a public website that the customers will interact with when they confirm their appointment.
Before we go any further, we did just mention something new, which is message queues, and we just want to talk about that a little bit. It's a pretty advanced topic for this fundamentals course, so we're going to talk about it at pretty much a high level.
Message queues are nice to use between applications for a number of reasons. They can help decouple them and make it so that one of the applications can just drop off something into a message queue and continue on with its work and not have to worry about what happens to the message after that.
Right, or if whichever application or applications it's trying to communicate with, it doesn't need to worry if that application is available and listening at that very moment. The message can sit in the queue, and when the other application is ready to grab it, it does. With a message queue, we're really just dealing with a single message. One application drops it, and the other one takes it, and then the message is gone.
Yeah, and there's lots of different implementations of message queues that you can find online. Some of them are free. Most of the cloud services that are out there now have these types of things built in as well.
And what we're doing here is dealing with a single message at a time in something of a silo app, since we control both applications that are communicating with each other. But sometimes you need to have a lot more flexibility than that. You might actually have a number of applications that are interested in that message, and you may not even know in advance or control those applications. So this is when something called a service bus comes into play.
Right. So you'll frequently hear about something called an enterprise service bus, and there's, again, a number of examples of these that you can find available. It usually sits on top of message queues and other features, and one of the responsibilities it has is making sure that messages get delivered to the different applications that care about that message.
It might even be an application that didn't even exist or you didn't know about when you were first setting up the message queue. So even at that point, because Service Bus allows you to decouple the routing of the message, it's possible to go ahead and hook up other applications to listen to the queue.
Right, so you'll see in our scenario that we have our scheduling application raising an event that an appointment was created. And it might be that maybe in the future we would want to add some other application that wants to react to that event.
We could publish it to social media. Hey, I'm going to go see the vet.
Exactly. If we had a service bus,
We could simply wire up in our service bus for this new social media notifier service.
pick up that event. But with just message queues, as you'll see in our implementation, we would have to change our scheduler application to know about this new app and write to its queue because we don't have any advanced routing. Everything's hard-coded in our simple scenario.
The message queue we are using is RabbitMQ. It's a mature, open-source message broker that you can get set up and running with zero install by using a pre-built Docker container. It has a lot of capabilities, but we're keeping it simple and just using it to define a few specific queues, which our separate bounded contexts will use to publish and consume events.
Now let's take a look at how we're adding message queues into our solution. The first part of the process happens when the appointment is scheduled. And you've already seen our Add New Appointment method inside the Schedule aggregate root. And you saw how the domain uses domain events and domain services to notify the user interface if there's a conflict in the schedule. In the previous module, we showed you Mediator, which we're using to publish these domain events. And we also talked about integration events, which are structured to be shared between different applications. So what we're going to do in our system is add RabbitMQ into the mix at the same point where Mediator is publishing the domain events. But we'll ask RabbitMQ to publish our integration events. These events will be formatted as JSON data before they're inserted into the queue. So let's see what this looks like in the application. We'll be looking at the code that makes all of this work a little further on in this module. We'll go ahead and create a new appointment. Let's bring Samson in to see Dr. Jones again. So there's the appointment. Nothing has changed from the perspective of the user. RabbitMQ includes a user interface to inspect the queues. And in the Front Desk app, the menu has a link so that you can open up this admin page and see what's going on with the queues that are associated with this application. We'll head to the queues page and then drill into the Vet Clinic public queue, which is a queue that we set up to handle communication between the Front Desk app and the Vet Clinic public app. And you can see that the one and only message that RabbitMQ is tracking is in that queue. So we'll drill into that queue and then scroll down to see the details of the message itself. And the most interesting part, the payload, which is the JSON expression of the event data. You can see the GUID value of the appointment ID, the client name is Julie Lerman, an email address, which is not really my email address, the patient name is Samson, and other relevant details that came from the integration event. So the Front Desk app knew to publish the message to this queue, and our Vet Clinic public app knows to read from this very specific queue in order to perform the task of emailing the client. Now that the message is waiting in the message queue, it's time to read the message and act on it. And acting on it is the next step in our workflow, sending an email to the client to let them know about the appointment they've just scheduled. We can't do this easily from our scheduler application because we need for the user to be able to click on a link that specifies that they want to confirm their appointment. So it needs to be publicly accessible.
So we've decided to put this on the veterinary clinic's public website. And so that will be responsible both for sending the emails and for hosting the link that the customer will click.
The public site uses a hosted service to periodically check for new things in its queue. Once it finds a message on the queue, it will retrieve the information from that message to create a confirmation email using code like what you see here.
One of the most important pieces of this email is a link back to the public website, not really localhost, which includes the GUID that represents the appointment ID. The website then sends the email. That's what the user will end up clicking on in their email and trigger a confirmation using the website.
All right, so now we're looking at the Vet Clinic public website, which is a super simple demo solution that we put together. And one of the things it does when it starts is start checking for messages, which you can see here.
Right, but we don't have it running quite yet because it would have already pulled the message out of the queue. First, we'll show you the code that's making this all work, and in a bit, we'll step through while debugging.
The public website has a hosted service called Front Desk RabbitMQ Service, which periodically checks the message queue to see if anything new has arrived. As soon as it finds one of those messages off of the message queue, it's going to send an email, and we're going to use a tool called Papercut, which will emulate a local email server for the purpose of testing. Rather than installing this on our dev machines, we're running a Docker container to host Papercut. You can view emails Papercut has received by clicking the Sent Emails link from the Front Desk Apps menu. Currently, there aren't any emails in Papercut, but as soon as we start the web application, it's going to check our message queue and then send an email that we should see appear in Papercut.
There's the message, the same message that we sent out for Samson's appointment. There's a hyperlink that leads us back to being able to confirm. Let's see first, high level, what happens when we click on that confirm button. And then we'll come back and click it and watch it in action. So now the user has the email and their beautiful confirm link in the email. When they click that, it opens up the website, browsing directly to the GUID that was their appointment. And in response, the website calls its own method called confirm, which takes the relevant appointment ID and pushes it into another one of the queues. You've seen the message queue that was used for relaying a message from Front Desk to the public website, and that was named FDVCP Vet Clinic Public In. Try to say that 5 times fast. But you can have as many queues defined in your system as you need. And one of the other queues that we've defined is for relaying messages from the public website. In other words, when the client has clicked on the button to confirm their appointment, back to the Front Desk app. Now that the email's been sent, let's see what happens when the client clicks on the confirm link in that email.
When we click on that, we've now confirmed the appointment. Once the user clicks on the confirm link, it drops the message with the confirmation back into the scheduler queue, and you can see that message right here.
Yeah, this middle queue shows that there's one message. Let's look at it. We'll scroll down to the Get Message button, and the message is retrieved and displayed. We've seen this before, where the payload is the JSON data we're looking for, and this one contains the appointment ID that's just been confirmed. Now you can see that the two different applications are communicating back and forth with each other using their two separate message queues. We've named the queues so that it's clear which applications are using them to communicate and in which direction. The initial acronym specifies which two applications are involved. FDVCP means Front Desk and Vet Clinic Public. The latter part of the queue's name says which app is listening to it. The last step now is for this confirmation information that's sitting in the queue to get back to the scheduling app.
Now, in our scheduler application, we have implemented a hosted service just like you saw in the public website. This one is called the Vet Clinic Public RabbitMQ service, and it listens to the appropriate queue to see if there are incoming messages that it needs to deal with. When it finds one, it responds to the appointment confirm link clicked integration event, yes, it's a long name, with the email confirmation handler. The handler looks up the appointment from the appointment ID that was contained inside of the message, and from there, it calls appointment.confirm. Appointment, as you recall, is our entity, and its confirm method also then triggers some domain events, which, for instance, our user interface listens to, and when it sees that that event has been fired, it triggers a change in the UI, enhancing the appointment with a green bar across the top to show that the appointment has been confirmed. Okay, so all that's going to happen at this point is that when the message comes through, it's going to make the Samson appointment right here have a green border and pop up a dialog to let us know that a change has occurred.
Very slick. This is actually really easy to implement because we already had the website listening for events. Remember how it was able to display new appointments and display conflicts. We implemented another design rule based on a particular property of the appointment, which is confirmed. All we did was set up another event handler.
We wrote the original sample for the first version of this course in 2013. At the time, things like SignalR and WebSockets, as well as emails with confirmation links, were relatively rare, although we certainly didn't invent these kinds of app interactions.
Right, but now every time I make an appointment for my dentist or hair, and even for Samson in real life to go to the vet, I'm getting texts or emails with exactly these kinds of confirmation links.
I know. I guess maybe a lot of businesses watched our course. Now we're going to take a deep dive into the code that makes all this work, and we'll go through it step by step so that you can see how all this is wired together.
And we'll do that by literally just debugging through the whole process so you can see how all the code links up.
Remember, all of the code for this sample is available on GitHub, and we encourage you to run it yourself to really understand how it works. The README file has instructions for running the solution using Docker, which is the recommended approach if you just want to see it running. There are also instructions for using Visual Studio or VS Code, which you'll need if you want to debug the apps, as we're about to do. For instance, I need to run RabbitMQ and Papercut using the Docker commands shown here before I can debug the app, as we're about to see.
We're back in the Vet Manager, and the user is on the phone with Steve, who wants to make an appointment with Darwin. Everything works just the same way it's worked before. We'll go ahead and add a new appointment and save the appointment, which triggers the schedule aggregate routes add new appointment method. We'll leave the locals window open while we're debugging so that if you want to pause the video and take a look at any of those values, you can do that. We haven't changed anything in the method. The only thing that's different is that now we've got an additional subscriber that's listening for this domain event, this particular domain event, the appointment scheduled event, to be raised. So we'll go ahead and raise the event and watch what happens.
At this point, we're looking at a new class that we created, which is this Relay Appointment Scheduled service. And what it's responsible for is creating the event that is going to get pushed onto the message queue that the public website is listening to.
This is the new piece of logic that's listening for the event that we just raised.
You can see it's listening for Appointment Scheduled event, a domain event. And in the method, the first thing we do is to create the Appointment Scheduled integration event that represents our cross-domain message that will be sent using RabbitMQ. The functionality we need from this event right now is to be able to send an email to the client, so we make sure to include all of the data that such an email would require.
Now we're in the publish method that lives inside of Rabbit Message Publisher, and that's inside of an infrastructure project. We've moved out of the core domain, but this is still part of the main front desk scheduling application.
Yes, and what it's responsible for doing is actually getting that message into a structure, a format, that RabbitMQ can use. That means putting things into JSON format in this case, and then actually sending the message. Once this fires, we should be able to inspect the message queue in RabbitMQ and verify that our message has actually been queued up for the vet clinic public input queue as expected.
That's what we did before, but this time we're actually seeing the code that's making all of this happen.
Alright, so that completes the actual thread of the UI. The response is complete for this part of the application.
Now we'll pause this and switch over to the vet clinic public application. We've just started it up again, and we've shown this to you before. Now we're going to watch the flow of the code after the hosted service starts up.
Jumping to the next breakpoint, you can see now we're inside of the actual handle message method, which gets the message as a string. It's responsible for parsing the string using JSON and deserializing it into an appropriate type. This is just demo code, so it's not the most reusable or elegant, but it works for this app. Remember that any change to the integration event in the front desk app will require changes here as well, which is one reason why a shared package can be useful for keeping applications in sync.
Once we've deserialized the message into a command, we use Mediator to send the command and a separate handler to actually send the email. This keeps extra code out of the hosted service and lets the handler use dependency injection to get any services it needs. In this case, it's an implementation of I send confirmation emails called Confirmation Email Sender. It's the service that builds the email with its details, including the URL behind the confirm link in the email that the client receives.
Remember, the whole reason why we need a separate app to implement this feature is that the end user needs to be able to click a link that goes to a public location on the internet. The front desk app is an internal app that runs inside the vet clinic's network, so it's not accessible. The public website is a good place to send users, and while they're there, they can get more details about the clinic or buy something from its theoretical online store, etc.
After the email has been sent, we can see it in Papercut, and opening it, we can see the confirm hyperlink. Clicking the link brings us back into the vet clinic public application's appointment controller class. This endpoint simply creates a new event. This is the one with a really long name, appointment confirmed link click integration event. Unlike the name of the event, the message itself is really simple and just includes the appointment ID that was confirmed and when it happened. The controller action then sends the event using a RabbitMQ message publisher that's identical to the one we just saw the front desk app use.
However, this publisher's destination is actually a different queue, the front desk input queue. Technically, the front desk